Hello, everyone. If you can hear me, please say something in the chat so we have a sense of the delay. And we are excited to be here for the last session of 2020. This year, that was a whole decade, potentially a century. I'm not still sure how long this year was. Loud and clear. Good. Hi, Brad. Good to see you. Hello, everyone. Hi, Melanie. Hi, Alex. Hi, Harrison, Jeremy, Jonathan Flowers. Awesome. Hi, guys. Hi. We're very excited to be here. Each week is a year. I agree. It's been quite the year. And quite frankly, there is no real reason to believe that with the turn of the clock and the announcement of 2021, anything is going to change really, because years are constructs. Anyway, hello, friends of the Salon. We're delighted to be here with you for the last session of 2020. As a reminder, we are a weekly salon where we gather with friends and colleagues to discuss in the tradition of 19th century salons, maybe, or maybe a little bit later, early 20th century salons. We are respectful to each other, have flat hierarchies and socially progressive norms. We encourage everyone from any discipline and any stage of academic stage, whether you're a student or you're starting or you're not affiliated with academia. We encourage you to ask your questions in the Ask a Question area or engage in chats in the chat area to ask for clarification or other things. And a reminder that Kanaka and Brad, Claire and Eva are behind the scenes, and Kanaka and Brad help in the chat for clarification questions. I want to also thank personally Kanaka for sending me a fantastic cake that I have been consuming, and it has really helped with processing grief and other issues. So I really want to thank Kanaka for the cake, in addition to clarifying questions and helping us scientifically. Remember that you can ask your questions in the Ask a Question area, but please ask even now, start now, because there were so many topics that we had over the past that were left to be discussed further, and this is the time. And we're just going to give you a couple of cues and start the conversation, just so that you all will start to you will feel the questions bubbling up from within, hopefully. I just want to remind everyone to be mindful of each other, be respectful in spite of being intellectually in conversation. Passionate disagreement is completely okay, but with respect, and also hopefully not with intellectual laziness. So it would be great if everyone also doesn't just ask others to process something for them, but actually engage in, looking for resources, finding things out, sharing resources with others. So we really encourage this kind of thing so that we all move together. Claire and Eva, I just want to do a round of applause for Claire and Eva, because they have been pretty fantastic. Hi, Kanaka, you just missed me appreciating your cake. And so, yeah, Claire and Eva, we really want to thank you. Just did a round of applause for you if you were here. And without you, the website would not be there. Without you, a lot of the scheduling and a lot of other things wouldn't work. So we really want to thank you for everything and your constant suggestions that have helped us improve. One thing in addition to that, and very related to the role that Brad and Kanaka and Eva and Claire have had in the salon, is that I think what this salon has made me learn over the past, 15 weeks now, which is crazy, is that we are an ecosystem. This gathering, we're not necessarily just individuals who are talking to each other and pushing individual opinions. We're like an ecosystem of philosophers, neuroscientists, computer scientists, psychologists, cognitive scientists, people from other fields who come together. And through these discussions, the dialogue that we create, the space that we create for evaluating different ideas and rethinking certain ideas is almost like an ecosystem by this point. I don't feel that kind of a boundary as much as an individual or as a representative of one discipline. I feel like we have all sort of become like a community that works a little bit like an ecosystem, and everyone participates in a way that has become, I don't know, indispensable for me or irreplaceable in an interesting way at the Salon. So I want to thank everyone for co-creating this ecosystem with us. And I hope that we can have it to be sustainable and we can engage in these kinds of discussions over the next year as well. With that, I'm going to give a moment to John and Jovo to say a few things if they want, and then we can dive into discussions.
Yeah, I wasn't thinking about saying anything, but surprise, surprise, I will find something to say. First of all, I think the Salon in general has been a surprise. I mean, it'd be very interesting to know if we reran the whole experiment again, whether it was COVID in particular that gave the impetus to it. I don't know. I'd like to think that there's room for the Salon in any time. The second thing is I've noticed a lot in Twitter and in other sort of social media platforms that there is a need for everyone at whatever stage they are in scientifically or whatever discipline they're in to be able to opine a little bit, to ask some questions and to take some risks. And I have noticed that this has allowed people to feel a little more bold, ask hard questions, maybe the night after change their minds. So I hope that people realize that there was and there is a value to different disciplines coming together and debating and disagreeing. And I think it's rarer than we thought. And I think that's great. And even podcasts, it's not as easy to call in a podcast as it is on a Salon, and it's nice to see faces. So I think it's unique. Before we switched on, everybody, the three of us were arguing about how you can be heavily into your field, computer science, AI, neuroscience, psychology, and not ever really have to spend much time asking the foundational questions about your specialty and its relation to others. That can go stale. It can actually not even be a requirement. And when you are asked to explain, why did you pick this discipline versus another? Why did you pick this model system versus another? Why did you pick this task versus another? You're forced to suddenly come to a very, I would say, glib generalization. You have to sort of say, well, this is going to lead to this. This is a model for that. Obviously, this is a mechanism that is general. In other words, one is put on a kind of defensive justification for one's choices because one hasn't really had to have extended conversations about the foundational opinions, assumptions, and of your area. So I think what we'd like to come away with in the junction of psychology, AI, and neuroscience is that we're better, with the help of the philosophers, at having articulate, extended, sustained discussions about the foundational assumptions of what we're up to. Because I do believe that leads to higher quality empirical and theoretical work. And that's what I'd like to think is the meta lesson from what we've been doing here. And that we should encourage it. Little bits of the Learning Salon should inject themselves into graduate programs, into classes, and that it should be a spirit of something that should be more present than it is. And that's what I would hope for. And I'll stop there.
Cool. Yeah, I didn't know I was going to say anything either, so I'll just make something up on the fly as well, which is, we were, like 4 or 5 months ago, I started essentially socializing on Twitter rather than in person because that was what was available to us. And I noticed that often Ida and John were saying things that I wanted to hear more. And so I'm just so grateful that we've been able to hang out together so much, and have everybody else here with us, because I've learned so much, including the things that they just said and so much else from people asking questions, people answering questions, in the chat and speaking and being our guests. And it's just been so great to be a part of this community. And yeah, I don't see any reason why it has to stop when everyone hopefully gets vaccinated. I started a class in the spring, which is just this salon. So hopefully we'll get, the translation from kind of classical academia with credits and stuff to things like this will become more prevalent. I just think it's such a great place for people to think, in a place that's free and safe, and supportive, hopefully. I think more of that is going to be great.
Yeah, safe and supported disagreement sounds like something that we need more of in academia, where disagreements are not fearful of the hierarchies that might squash someone, or being ridiculed or whatnot. I think that I've seen a lot of people have difficulty asking questions, especially people from underrepresented groups. And I hope that this kind of a exercise in dialogue-based discovery of ideas just makes it, it's totally okay if somebody makes an error in something that they say, or, a question they ask. This is the place to just, figure it all out together. So I think that supportive space for disagreement is very important.
And also just another meta point is that you can have scientific papers with their abstract, introduction, methods, results, discussion, and talks on slides, and never have any of all this, right? So in other words, then you have to ask yourself, is this part of science, or is it a conversation that can be had on the side? Is it dessert, right? Now, Ha-Seok Chang, who I'm a fan of, has talked about philosophy as complementary science. In other words, he doesn't think it's just commenting on science. It's actually a part of the science that just doesn't get as much play. Of course, philosophers do it, but you don't have to have it at an SFN or in a paper or in a regular invited talk. No one's asking for this bit. But I think that I like the Ha-Seok Chang position, that actually this is a component of science that needs as much airtime as what we're traditionally doing when we're going online, going to conferences and writing papers. So it's a missing part that shouldn't be considered a luxury or dessert, as I said. And I'd like there to be more of it.
I'd like to add a caveat perhaps to that, which is I actually think it is demanded of us, but it's demanded of us in a way that we don't fight it. So in other words, every grant that we write, we have to say, this will make sure that we solve depression if we do this experiment. And that argument isn't picked apart, but the details of the experiment of whether you use like 5 milligrams or 10 milligrams, or whether we compare to this AI algorithm or this other AI algorithm, those are torn apart. And the much more important, perhaps, nuances of why you would do the experiment at all are often ignored. And I think...
Yes, I mean, Francis Crick was famous for asking, why did you do that experiment? And it's not the question that one was expecting. It was more, so exactly how much reagent did you use? And what genetic strain precisely of mouse? And the questions all get taken up on those details. And I would wager that one of the reasons that the questions take up those details is it's a tacit agreement in the Kuhnian sense of not rocking the boat. Let's not ask why we're all here. Let's not question the starting assumptions, because then it gets very queasy and inducing very fast. So let's just talk about exactly why did you paint it red versus green, right? And I think this is a counterbalance to that, which is we'd like the questions to be proportional to the largeness of the assumption and not get lost in the details, which is, I'm not saying unimportant, but question sessions are awfully swamped by those detail-like questions.
So with that in mind, I think that there were some greatest hits in terms of a theme that some of the themes that kept recurring across a couple of different sessions that we had. And so I might forget some. So people, please, if you remember some kind of a greatest hit or some recurrent theme that I forgot, we should, Melanie says you should have someone else first, not me. Okay, we promise you that, Melanie. But in spite of the fact that she, again, has the highest voted question. But the burdens of being popular. So here's what I want to say. Some issue that seems to be recurring was functionalism. It seemed like a lot of our neuroscience, discussions seems to evolve around the confusion about where people stood with regards to functionalism. And we also had the fantastic opportunity to hear from Masvita that she happened to have arguments from the philosophical side against functionalism. So we had this diversity of some of us who are functionalists, and Masvita, who's not a functionalist, but from a different angle than the anti-functionalism of neuroscience. So if there was a spectrum from only individual neurons matter to the entire ecosystem might matter, if there was a spectrum like that, it seems like functionalists occupy somewhere in the middle. And it seems like the anti-functionalism of some neuroscientists is towards the direction of only neural circuits matter, and the functionalism of the anti-functionalism of someone like Masvita, it seems to me, is towards the extended cognition and ecosystem level. And it was interesting to me because I think I empathize with that other direction a little bit more. But I think that I'd like to maintain a kind, maybe we can think about it in different ways even. But that was one thing that came up over and over and over again, especially with regards to the necessity of starting, which species to start from and such. So that's the one thing that I wanted to bring up, and I will bring it up again. So for those of you, so someone is asking about something that we don't discuss. So this is for discussion of topics that have been recurring in the past. So the post-publication peer review is not something that we've discussed. So we'd love to stay on, if it's okay, I'd love it if we stay on topic, on the conceptual topic, because these are very excellent questions, just not for in the scope of the talks we've seen. Another theme other than functionalism, which we can discuss hopefully, that I think recurred was memory structures and functions of memory. This appeared across different talks, whether it was the computational models of memory, whether it was how do we conceptualize memory, human memory or rodent memory, and what's the relationship between that and AI. Another thing was something that started to be striking. The more nature documentaries I watch these days, like a lot, that's like a really large number of nature documentaries over and over they're on. And what I realized is why we are so focused on C. elegans, flies, rodents, monkeys, humans. And then you watch these nature documentaries, there are so many crazy, awesome algorithms that are going on. And so something that I wanted to mention that came up a couple of times is Peter Godfrey Smith's Other Minds, which is exploring, for instance, evolutionary aspects, and then talking about the minds of octopus, for instance. And this connecting to the idea of functionalism, or to the more ecological ideas that I think Masvita hopefully will be here to talk to us about. And then so this was something that I keep thinking about. So I want to leave the question for everyone here when we reach that point. This is just a menu that I'm giving. Can you guys in the chat leave in one line 3 species other than C. elegans, rodents, humans, flies and monkeys that you would like to, for instance, observe the behavior or you think we can learn from. So for those of you who have some ideas, like what are your 3, like leave in the chat if you like. I just would really love to see what other species people would be. Yes, here's Metazoa for answer to the question whether I also have Metazoa. So yeah, so while people are putting those there, and I hope that people would sort of add some of their species, and don't get primed by others and say the same things. I hope that you have a lot of things. Songbirds, yes, songbirds are being studied and they're very important, and I would love to say more about them actually. Ants, elephants would be awesome. Their memory is crazy. Speaking of songbirds, one thing that I want to say, and John left, he doesn't like songbirds apparently.
Okay. Sing it for
What's
us.
that? No.
Sing the next thing.
What I want to say about songbirds is that in songbirds, some interesting thing that happens is that sometimes, for instance, the female of the species should listen to this other song and decide whether it's a good song or not. Sometimes gives feedback. If the song is changed, she's more likely to actually like this male as opposed to another one. The interesting thing that I was thinking about this is that these patterns, the songs are basically patterns. They're a pattern of sequences that are being generated. And a lot of times when we hear theory, basically what we are hearing is a pattern or a sequence also, a sequence of ideas, a sequence of thoughts and some kind of a pattern of thought. And I think it's important for us to start demanding new theoretical songs, if you like to start, really engaging with changing some of the songs that maybe it's been going on too long. Maybe some of the scientific ideas that have some, especially speaking of Kuhn and not rocking the boat and things like that, some scientific frameworks that are a little bit different than others. And no, I'm not talking about artificial grammar learning experiments. I'm really talking about our ability to sometimes get out of a sequence or pattern of thoughts that we are into in terms of theoretical work. So one thing was different species. Another thing is what kind of new ways of thinking, what kind of frameworks for learning or thinking can we come up with? And finally, something that keeps coming up was whether an AI is basically just adding layers to each other and putting things, constructing some structures so that it can solve a problem and chase a benchmark, or whether there is some other approach to it. For instance, is it learning common sense? Is it moving towards having common sense? Is it moving towards having semantics? Moving towards having meaning? Are there learning frameworks? What can we do? What kind of a learning framework can we use to get those things, like common sense, like meaning, like semantics, etc. So these are some things that I thought about. So I just wanted to offer this menu item and see if John or Jiva want to add something to it and maybe dive into some of them.
Functionalism is it's a huge subject philosophically, and it's got all sorts of flavors and variants. And there are people like Gualtiero Piccinini who will talk about mechanistic functionalism. Things that are seemingly binary opposites getting put together. And I think that the variant that I was trying to be a proponent of was simply that it is perfectly okay to have effective theories, borrowing from the term in physics, of psychological phenomena couched in psychological concepts. In other words, every field has its core ideas, its core concepts, its vocabularies. We all accept that without exception, right? We do not demand atomic theories of neural circuits, okay? So to the degree that there are effective theories that are to a large degree autonomous in psychology and cognitive neuroscience, that do not need to be couched in the vocabulary of neurons firing, neural biophysics, exact details of connectivity, then that kind of functionalism, I think, yes. in my view, it's unavoidable. Okay. And one position that we've taken up a lot is just because you believe that there are effective theories of cognitive and psychological phenomena couched in the vocabulary of the abstract objects of that discipline does not mean that one is a chauvinist with respect to where evidence can come from. So one can be completely open to having evidence come from all levels. Okay, but the point that I think people in cognitive neuroscience would make, that once you've gathered that evidence, you will re-articulate your position in the psychological language. Okay, you will not substitute the psychological language with neural language. So the position is that as you move from sensory motor phenomena in the spinal cord to cognitive phenomena in the prefrontal cortex, that neurons change their usage. They go from being in the explanation to being evidence for an alternative psychological explanation. Now, that's a kind of functionalism, but it seems to me an unavoidable and obvious one. That's the position I would take. And I actually challenged Buzaki on the podcast with Paul Middlebrooks, where he was talking about his annoyance at cognitive terms and concepts. And I asked him, so re-articulate the sentence without any of them. And of course he couldn't do it, right? So that's, I think, the medium flavored version of functionalism. And I don't see how really one would want to do away with notions of effective theories across the disciplines.
Do you mean folk psychology or do you mean functionalism?
I'm talking about just notions like working memory and prediction error and attention, and those are all very useful concepts. They don't need to be articulated in terms of neurons and their connections. That's what I'm saying. And so I'm saying that functionalism of the kind that I think has been most part of our discussion is there some effective cordoning off of psychological phenomena using psychological formulae, mathematical formalisms and notions that aren't just what Cravers calls sort of sketches waiting to be filled in by the neural details. And I think that is incorrect. And I think actually that he and Kaplan have gone back on that notion that they're just sketches. They are perfectly valid explanations as any other type of explanation.
So thanks for that. I identify as a functionalist, and I hope that we can get Masvita to be on screen. I know it's very late in Europe, so I hope that she has time to join us on screen. And John Flowers says that he agrees with her. So maybe we can have the philosophers on screen as long as like Masvita's time is limited, because she probably will leave us earlier than later. So if we could invite her on screen. She expressed availability. Then we can discuss this a little bit. I think that Masvita has this point which is different from the anti-functionalist. Oh, perfect. Hi.
Hey.
Masvita, I was just saying, I think that your sort of opposition to functionalism is on a different kind of scale or at a different level than some circuit neuroscientists. And
Right.
I appreciate it, because yours is more towards ecology and it's more towards embedded cognition. And I think theirs is more towards circuit level reductionism. Right. So I think we share the ethos of anti-reductionism, or minimal levels of reductionism that would be required to do science, as opposed to a complete reductionism. So I would love it if you tell us a little bit more about your oppositions to functionalism, especially with regards to both what John said and, given your talk that we recently heard.
Yeah. So I was coming in the chat. I was interested in what John said, because he was expressing that his main motivation for supporting functionalism was it seemed the only way to talk about, psychology having its own level of effective theory, which doesn't need, you know, racing to the bottom of like going into the neuroscientific details. And I think that's totally right, that there needs to be a way for psychology to express its autonomy. But I think it's unfortunate that intuition has become too bound up with all of these commitments about this psychological level being the level of computation. And I don't know if it's the influence of Ma, because that's very much how he framed things on that third level of explanation, because you can take that computational level and say, well, what it should really be called is just, you know, you need to look at systems like the visual systems as having some kind of purpose, or some kind of, you know, you don't know what, you're not supposed to use the word teleology anymore, but some kind of reason for them doing what they're doing. And because, you know, concepts like teleology in biology are frowned upon now, I guess it was considered much more respectable to make these analogies with machines. But then I don't think computation captures everything that we need to express to properly understand cognition in animals.
You're muted, John.
Yeah, just to, I mean, I think also I notice, I mean, you know, this, it's very interesting that there are people, and I'm seeing Paul saying, oh, but some psychological concepts are wrong. Yes, of course they are, and they'll be corrected by doing better psychology. The implication there is that we need our neural friends to correct us, please, right? And I have no problem with the idea of sending out your evidence hounds to help confirm, update, or even jettison certain psychological concepts. As I said, send out all your hounds at all levels. Okay. The other thing I would say, wouldn't you agree, Masrita, which is that the levels of Ma tend to be confused with the level of effective theories. They're not the same thing, right? I'm talking about the effective theories in economics, the effective theories in psychology, the effective theories in neuroscience, the effective theories in chemistry. We're not talking about different Ma levels at that point. We're talking about what the objects of explanation are.
Right.
Unfortunately, what happens is people equate effective theory levels with Ma levels, and that was never the intention. And so you're right, what happened is because the top level of Ma was computational, and psychology is on top of neuroscience,
right,
that they got equated. And I completely agree with you, but that's not my fault or our fault that people get confused about two different ways of thinking about hierarchies.
Sure, but then what you see in, you know, the disciplines today is that there's this equation with being an anti-reductionist, with being a computationalist, and so, you know, all of these commitments that I was pushing back against in my presentation here, which was about, you know, these computations, you know, literally being performed in the brain just in the same way that they'd be performed in a digital computer. And I think they're the commitment to functionalism are also about medium independence or substrate independence. I don't think there's anything scientifically compelling about that, you know, from what we know about cognition in animals. So it seems that people adhere to that more from, you know, from this antecedent philosophical commitment to functionalism, and therefore, you know, strong multiple realizability. And then also it fits with this program in Strong AI, which is all about, you know, building general AI in machines.
Yeah, I think that the computational theory of mind does depend on talking about substrate independence, right? In other words, I agree with, you know, Milkowski and Piccinini that if you're going to adhere to the computational theory of mind, you're going to be talking about computation over a state or a representation that can be articulated in a substrate independent way. Now, as you know, they're not uninterested in substrate. In fact, I think Piccinini's claimed that if you say you're not interested in substrate, even though you have a substrate independent definition, which he agrees with, it's a dead research tradition in the Lakatos sense. He feels like it's a dead end. interestingly, but the subtlety of believing in substrate independence, but being interested in substrate can get lost on people. Wouldn't you agree?
Yeah. And but I don't see, but I don't find it a very coherent position to say that, you know, what they're doing, you know, in terms of how they account for computational explanation in neuroscience, saying that, you know, neural computations are neural computational systems have these evolved teleo functions and they're computing, and this is a substrate independent notion, but at the same time being interested in substrate. So maybe it's just too subtle for me, I have to say.
Okay, I think that there's a minimal functionalism here, which maybe multiple realizability is a better way to talk about the idea of substrate independence. So it's not that there is no substrate ever, it's just that there are multiple different substrates that could underlie the same type of cognition or mental state. Do you think that's a valid idea, regardless of computationalism? Just the idea that different substrates could underlie a similar enough mental state that we could consider them the same?
Yeah. So I think there is an important notion that comes out of looking at biological systems, which is that, you know, what you find is robustness and degeneracy. So, you know, Eve Marder's work really put me onto this, just showing that you can get this physiologically pretty sustained performance in the somatogastric system. These neurons carry on, you know, doing the same, churning out the same rhythms, but there's all this churn going on in the ion channels and all these different parameters. So I think it's really important to take account for, the same cognitive performance can be sustained over different realizations in that sense, you know, different physical parameters in play. But that doesn't mean that you could get the function of the somatogastric system in silicon or in Swiss cheese, as the functionalists used to talk about. So that really strong notion of substrate independence, we need to be pushed back against. But I think one of the reasons people were talking about multiple realization so much was that it seemed to be latching onto a genuine biological phenomenon, which is robustness and degeneracy.
Okay, so I think I'm still not clear about this. For instance, so a book that you and I seem to both like, and I mentioned this earlier, and also a follow-up book that's also related to that, both of them by Pierre Godfrey Smith, and the beautiful documentary that people can watch, My Octopus Teacher. It seems like there are certain mental states that I could ascribe, like hiding, like deceiving the shark, like experiencing some kind of pain, like playing with other species, like being exhausted, like being sharp, being curious. It seems to me like those things I can ascribe to octopus, and it's very different. It really departed evolutionarily a very long time ago. I'm trying to see where your notion of multiple realizability ends, and after which is it no longer for you okay? So it seems like not okay at all, or it seems like there's no kind of computational mental state that you can accept that this could be an equivalent of a mental state in a biological person. That's my understanding. But I do wonder now about octopus versus mammals, for instance.
Yeah, I mean, I think these are the really puzzling and interesting cases, because, I mean, strictly speaking, with functionalism, it's a view, and why I was saying in that email that I see it as, you know, ultimately growing out of behavior, because it's saying that how we define a mental state, it's not pertinent to consider the first person experience of the creature whose mental state we're defining. So the behaviorist looked, strictly speaking, at what was, you know, observable from the outside, and then that didn't work. So then there's this move of positing inner states, which show how you would get, you know, different behaviors given different preconditions within the cognitive system of that creature. But the first person experience of the creature was not relevant to defining the mental state. So if you go down that line, yeah, you could say an octopus is in the same functional state, i.e. as a mammal, so in the same state of pain. And then, strictly speaking, with that functionalism, you don't need to worry about what the experience of the octopus is. But maybe I'm not happy with saying that pain is multiply realized in the mammal and in the octopus, just because it bugs me that I'm leaving that question of the experience out of the equation now.
So the challenge that I see with this, and thank you for saying that, and the reference to what you wrote in the email, that whether functionalism grew out of behaviorism, which is a position that you hold. And it was very important to me to hear your thoughts on this, because in my mind, a very important distinction between functionalists and behaviorists is that functionalists actually do care about the algorithm and what's in the black box that leads to a particular behavior, but behaviorists don't. So in a very important way, functionalism is anti-behavior.
Yeah. So they care what's inside the black box, like in between, like stimulus and response. So for the behaviorist, what was in between stimulus and response was just black box, and they didn't care about that. The functionalist, looks at how stimulus and response are connected within this cognitive mechanism, which we could talk about as algorithms. But what they're not interested in is what's in addition to those relationships between stimulus response and then these cognitive things. And that's what I'm calling the first person perspective on the creature. So as long as the right relationships are there, and these could be cashed out as algorithms or computational structures, but not the first person experience.
Paul,
I just wanted to add something, which is actually a few points back. First of all, I'd just like to make one really quick comment. I think it's great that we're actually having these kinds of conversations, because I think the biggest problem is that not enough people have these conversations. So I just want to thank you guys again for making this kind of thing happen.
Yeah, thank you. I'd like
the thing I wanted to say though about multiple realizability is that I agree with the concept of it, of course, to some extent, but there's a little bit of it has a sense of Platonism, as though there is such a thing as pain that some animals then realize through the mechanisms that they've evolved. It's a little bit like there's a Platonic solid that exists of this thing called pain or this thing called thought, and then we're asking questions about what kinds of physical instantiations will create that thing. But I think that's a pretty, I don't know to what extent people are thinking of it that way, but I think it's pretty precarious to think that there is something that these different animals like an octopus and a mammal have arrived at that was somehow there to be discovered, because I'm not really sure that's the case in terms of psychological phenomena. I think biology shows us that there's an incredible diversity out there. Anything we can possibly imagine, nature will give us another example of something different. And I think in the case of some of these psychological concepts, and comparing something like pain in an octopus and a mammal, there is a functional similarity, of course, and in terms of what the idea, this concept of pain would serve the animal for learning, for withdrawing from dangerous stimuli, etc. So in a sense, there is something functionally at that functional level that is actually realized differently. But many of the other things, all the other levels of understanding that I think are also important, are not necessarily going to be the same. And it's going to be more similar for different mammals. It's going to be more similar for different humans, obviously. But all the levels are probably going to be similar. But I think the idea of these conversations we have, whether thought is multiply realized, it's dangerous to make that assumption. Maybe I'm wrong. Maybe people are not making that assumption.
I mean,
it just seems that the kinds of questions that are being asked.
So let's just talk about that just a second. And multiple realizability, I think, to be honest, the kind of notions that we've been talking about autonomy of psychological explanations, computational theory of mind, it shouldn't, and I agree with you, hinge on multiple realizability. Okay, multiple realizability has two versions, right? One is that you need to show it in order to justify the lack of mapping ever being possible one-to-one between reduction and explanations and the phenomena, which is how it was originally considered. Okay. The other one is this notion of pain. You see, as Cummins pointed out, another philosopher, you lose the phenomenon of interest if you go down too low. So in other words, he uses the example, I think, or someone talking about him, of the doorstop. I think I've talked about this before. The doorstoppishness of a doorstop is a conceptually useful idea that is true whether the doorstop's made out of wood, glass, clay, or whatever else, or a foot, right? So in other words, by going down into the details, you lose the clarity of the concept, okay? So in other words, that's the point, is pain. If you go down too low, you'll lose the very thing you're looking for. And Strevens, the philosopher, has a very wonderful book out recently, has talked about this, is that if you start looking for differences between the octopus and the mammal, of course you'll find them. That's the whole point, is that you'll get lost in the differences and you'll have moved away from the functional similarity. You can't have your cake and eat it, which is to find differences and then go, I found differences. Therefore, the original phenomena can't be the same one. It's not.
No, I'm not saying that.
It's not a doorstop.
I'm just saying that in order to understand the similarity, you kind of have to understand.
No,
you kind of have to have a good definition of the thing that you're looking for. In the case of pain, I think it's a pretty safe concept to say that is something that's pertinent to these animals, and that is something they multiply realize. I just think it's tricky in other context.
Yeah, I mean, I would say, from a biologist, behavioral scientist perspective, looking at animals, it's easy to say that, sure, this behavior is multiply realized because we can see that there are these similar responses, etc., etc. From a philosopher of mind's point of view, we're interested, to begin with, in human experience. And so this first person perspective is not something that we want to lose sight of completely. So there's this other motivation there for thinking, well, if we just talk about, what's functional in that biological sense, and obviously having these withdrawal mechanisms and these behaviors that obviously has this evolutionary function across the animal kingdom, then that's fine. But then there's this other issue about experience that we can't just extrapolate from similar behavior to a similar experience. And when philosophers talk about mental states, they don't, philosophers like me, don't want to just exclude first person experience out of the equation there, though other philosophers would not care about that.
Jonathan.
Flowers is next.
Yeah, so one of the things that to go all the way back to the beginning, one of the things that I'm noting is that I think the analogy, or the computational analogy that we're using, I think we can trace all the way back to a broader concern with the mechanistic analogy of organisms and bodies, which, we could look at Descartes for, right? Mm-hmm. The body as a kind of mechanism, and if we understand the mechanism of the body, we can understand and extrapolate outwards all of its functions, which I have kind of deep problems with. But this broader question of multiple realizability and pain for other organisms, I think seems to elide the fact that, one, organisms experience the meaning of pain for an organism is grounded in the context in which the organism has that experience of pain, such that it can respond to the environmental stimuli that produce the experience of pain. Pain for a human is experienced in so many different situated contexts that we interpret through our embeddedness and culture, e.g., pain for an ancient Catholic engaging in self-flagellation means something different than the pain that, say, someone in chattel slavery experienced in similar contexts of being whipped, than the pain of me stepping on a Lego versus stubbing a toe, and so on and so forth. The situated context in which we experience the biophysical response to our environment matters. So pain, even if we suss out the mechanistic properties of it, will not be the same pain, right? It won't be the same pain for me versus for another organism, which I think we can get us to things like rationality. To argue that rationality is the same across all organisms is to ignore, I think, one of the crucial insights from both phenomenology and pragmatism, that mind emerges in transaction with an environment, and an organism that has a different environment would have a different mind. And then if we read it backwards, right, an organism that has a different environment will have a different relationship to the stimuli that we could call pain. The meaning of pain for a cat is different than for a tiger, is different than for a lynx, and so on and so forth, right? Due to the affordances of their bodies and the ways they transact with the environment. So one of the things that I think we need to bear in mind when we're talking about the thing called pain, right, is that pain has a specific meaning that is supplied to us as humans through the ways we are in nature, through culture, that is not shared by other organisms, right? And the same for many of the other things that we seek to discern. So when we try to move across organisms, it might be helpful to bear in mind that our understanding of pain is grounded in a situated human context.
I would
And there's order. There's the order now. So raising hands in the chat for, okay, so
Yeah.
there is, I'm going to say something because I've been in the queue for a while now. And then it's John, and then it's Jovo, and then it's Masvita. So I am going back to give a comment about what Paul said earlier. Paul was saying something that I really appreciated. He was talking about multiple realizability, having a platonic flavor of a solid thing that is thought, and then it comes to fruition and across a number of species. I think this gets close to the metaphysics of mathematics, which I never thought it's a sentence I would say on this Salon, but I just did. And I also want to say that there are the same way that there are different ways of thinking about metaphysics of mathematics, there are also different ways to talk about the metaphysics or ontology of multiple realizability. I do think that if we do think in terms of algorithms, in terms of math, etc., we can think of something as having existed in ether in some place and just being solidified in some form or other. That's one way of looking at it. It's a very, very valid way to look at numbers or math. But another way that I think I prefer is that it could be an emergent algorithm or solution to an ecological problem that some different creatures were facing in a similar ecology, and therefore different creatures might have developed across different realizations or substrates, as Masvita likes to call them, similar functions, which for somebody who's math oriented like me have similar maybe maths when we want to capture some functions of it. For instance, what is learned from it? What does it enable? What does it help the organism avoid? So all I want to say is I loved that you you just drew that kind of analogy between multiple realizability and platonic solids, because I had never had the opportunity to say metaphysics of mathematics is key here, and also the opportunity to explicitly say that this ecological algorithms, what in fact, another book, Leslie Valiant in his probably approximately correct, professor of computer science at Harvard, pack learning is a very common approach in ML and machine learning, and what he calls ecorhythms. So ecorhythms, they develop within an ecology as a solution, and they're very far from the idea of platonic. They are something that are, again, the name is probably approximately correct. They're not perfect. They're not platonic at all by any means. They didn't live somewhere in some abstract perfect world and then emerge and occupy the bodies of some lowly creatures like us. But they actually arose as a solution that needs to happen in a short period of time, that you have a limited amount of time and resources and you need to get it. It's okay if you get it almost right. It probably is approximately right, but not, optimal. So I just wanted to mention that I really appreciate that this discussion allowed me to connect these two things. The next person is John Krakauer, and then Jovo, and then Masvita.
Yeah. So first of all, in terms of multi-realizability, I do think it's a bit of a red herring in a way. I mean, obviously we agree, right, that arithmetic can be done on an abacus, a calculator. You can do addition on many different substrates. So it's sort of trivially the case that there is a conception of a computation that is substrate independent. I mean, it's just not arguable, basically. Now let's get to the notion of multi-realizability. Pain's a very bad example, I think. I mean, because it's so subject. Pain and consciousness are equally difficult as far as I'm concerned, and I think pain can be used for the original C-fiber argument for functionalism, but I think pain gets very much into first person and body and subjectivity and culture. It's too difficult, basically. I agree. I think Zeno in the chat sort of said cognition is probably easier to deal with. I mean, I want to go back to to Paul's point in terms of this, and I think I brought this up in the Salon before, Strevin's argument about the body shape of the marsupial mole versus the golden mole. Now, these are two moles with completely different evolutionary lineages. They're even born differently. One's a marsupial, one's a mammal. Okay. So if you go to differences between these two moles, you'll find differences all the way back. But their body shape is functionally identical. Identical. Thick fur, big claws, blind, big snout. If you want to understand the marsupial mole and the golden mole's shape, going backwards in time like the doorstep is a waste of time because the explanation of their body shape is functional. An example from physics is the laminar flow of water. The Navier-Stokes equation applies to many different types of water. You don't need to know the structure of the fluid that you're applying the Navier-Stokes to. So the bottom line here is it depends what question you're asking. If you're asking a boiling point of water flavored question, you do need to know the atomic structure of the liquid you're talking about. If you're asking about the laminar flow of water, you don't need to know about it. If you want to understand what the body shape of the marsupial mole is compared to the golden mole, as Strevens has pointed out, it is completely irrelevant to go into its evolutionary history unless you're asking a second level explainer question, which is you'd kind of like to know how the marsupial ended up with its fur and how the golden mole ended up with its fur. But it is not the explanation for its body shape. That's a second level explainer. And I just don't know what the confusion is about here. Right? Sometimes you have to be functional. Sometimes it's useful to go down a level. Sometimes it's a first level explainer. And sometimes it's a second level explainer. It's just as simple as that, as far as I can see.
Well, that's true if you have a well-defined concept. I'm just not sure that's the case with psychological concepts. Furthermore, we are not just interested in describing cognition at a behavioral level. We actually want to understand it at a neural level as well. And you know, it's not as simple as the laminar flow of water then. I mean, I'm just saying that, yes, of course, there's a certain sense in which you can describe things in a functional level, and in which case, that, you know, even it doesn't matter, then we can have the discussion about humans versus computer can be conscious, whatever. But we don't know how the consciousness works, and that's true for many things in the brain. And I'm just saying, if we want to have that multi-level explanation, then, you know, at some points we need to know a bit more about, you know, certainly the ecological context.
Just one quick.
But I mean, I think in general, of course, I agree with you that these things are, you know, that there are many examples where we can be pretty confident that the higher level is sufficient. But I think as neuroscientists, we're not satisfied with that, right? We do actually want to know what the mechanism.
Right. No, but when you say you want to know, just I'll finish very quickly. The mistake I think you keep making is you think that you're going to move a second level explainer into psychological first level explainer position. You will not. All you will do is do some kind of constraint or restriction or confirmation, but you keep making it sound like that one day you'll have sentences with neurons in them rather than with psychological objects in them. And that will never, ever happen.
Yeah, but what if the psychological psychological objects are wrong. That's what I'm saying.
What if the neural explanations are wrong?
Well, then you're not asking good questions, and then the answers are not going to be that good. I mean, anyway, I don't want to take away from other people.
Just a clarification point on that. What John Krakauer is describing is eliminative materialism. And that has been even taken back by philosophers who proposed it as being too much or too extreme. However, Paul's idea of revising our psychological concepts in light of changes in culture or changes that we find, that's fair. That said, Paul, the idea that neural level explanations is the way to replace those or folk psychology, I don't think you were even proposing that,
no,
right?
I'm not proposing that.
Okay, exactly. So I think, John, you
It's
were...
going to be computational in some sense, but maybe not the same computation that we've been assuming for.
Yeah, but when you say neural mechanisms, you are making it sound like that.
Well, no. I'm not saying it has to be explanation entirely in terms of neurons. It's just, it'd be nice to be able to at least point at some neural substrates, discuss neural circuits, I'm not saying it's the only level. It's not a pure, again, I promise you, I'm not a naive reductionist.
Yeah, that's my understanding too. And also, John, let's recall that talking computationally doesn't mean that you're talking at neural level. You could be at a very high algorithmic level. That's basically the same as folk psychology, potentially. So.
My allergy is only to when it looks as though the ultimate tiebreaker, the ultimate bottoming out of explanation, when we know we're done, is when we have a neural mechanism for it. And all I'm saying is that notion that that's where we will bottom out and all can go home feeling satisfied is just
we'll never
erroneous.
get there.
It's an erroneous goal.
Wait, is that your goal, Paul? That's not how I understand it.
No. And we'll never reach that even anyway. But the point is, I wouldn't be satisfied with a neural explanation that doesn't reach the behavioral. No, not at all. It has to be. Anyway.
No, Flowers is after Masbita. So thank you so much, Paul. This was awesome. Jovo, go ahead.
So, it's always fun hearing John yell at Paul and all the other discussions here. But I guess as my lab, we don't do that much philosophy in the lab. We study brains, we study behavior, we make up new AI algorithms. And so I'm wondering if one or all of the five of you can help me connect, given these ideas that you're saying about functionalism or not, what does that mean to me as a practicing scientist? Like, what should I be doing more or less of concretely based on these ideas? Or is it just dessert?
Wait, sorry, everyone talks a lot longer, so I thought this is the intro to what you're actually going to say. What did you say? What did you ask?
I just want to know what to do with this.
What's the payoff of this discussion for the lab? Shall I come in here? So I wanted to say to Jonathan, I wondered if you were allowing for other animals to have like some kind of social contextual relation in how they experience pain, because I think that's something we should be open to and not just think that human social context is something that shapes our mental states, but not allow that for other animals. But I didn't know if you were implying that or not. But yeah, what John was saying about the moles and one being marsupial, I think that like put some clarity to what I was trying to say before, which is just that, sure, if you look at their deep evolutionary history, you might say, well, they have nothing in common, so all we need to look at is the function. But I think there's too much of a leap to say, therefore, the neural mechanisms or just the kind of material that their bodies are realized in does not matter. So say we're talking about two animals with different evolutionary histories that have some presumable cognitive state in common. Well, they do have some really important things in common materially, even though their evolutionary history is so divergent, which is that they're made up of metabolizing cells and they have neurons, right? So I think there's too much extrapolation going from this functionalist view, which is that, sure, there is this level of there's this level of similarity with function, which suggests that there are certain differences that don't matter, but then we're not focusing enough on what those two animals might actually have in common. And because we're not focusing on what they have in common, then there's this other leap that's made to saying, oh, well, you could realize the same cognition in a computer, which is just a completely different kind of physical realization, because one's alive and one's not. So I think that's just this thing that needs to be taken into consideration. There's still some commonalities that are there, but it doesn't mean that you need to look at all of the details of neural realization to explain what's cognitively similar about those two creatures.
I mean, I don't disagree with that in so much that if you're going to apply Navier-Stokes to fluids, you have to apply it to fluids, right? So they're fluids, right?
Yeah.
So but I think there's a difference again between the level of the explanation of a phenomenon, going to all levels to update it, change it, revise it. But I'm not saying that it may well be that you can't have that body of a mole. We all know, I've said this on the mole can't have a rotating corkscrew on its nose, right? We know there are limits. That's not the point I'm making. The point I'm making is that when you come up with your explanation, it's going to be functional. That doesn't mean that you're ruling out that there are some things that are just out of the question, like having a rotating corkscrew or something like that. I mean, that's just not the point. I'm just saying that the explanation is functional. It doesn't mean that there aren't constraints at lower levels.
Sure, but there are some peculiarities that come with computational explanation, because when you're talking about a computation, you're talking about something which is by definition medium independent, because you can have computations running in whatever device as long as it has the right structures there. So that I guess that's consistent with what you're saying, that there would be some physical constraints. But could you have a computer made out of jelly? I guess you couldn't, because it would be too floppy.
But sorry, I don't see how that.
Yeah. So to Jovo's question, this gets to Jovo's question. I'm tired, so I'm rumbling a bit, and I'll shut up. But to Jovo's question, I think what's sort of bugging me behind the scenes about this is the way that functionalism sort of feeds into this, all of the research activity behind strong AI, or the notion that you can artificially create human-like or animal-like intelligence. And I think that is, obviously, it's a very popular idea because of the successes of AI, but I think that's leading us to miss what is distinctive about biological intelligence. And there are reasons that we should take those things seriously. So to Jovo's point, what difference does it make to someone in a lab? Well, I guess all I'm doing is throwing a bucket of cold water on the idea that there are certain ways that you could recreate biological-like intelligence.
So I want to address that. So the actual order is Flowers and Paul for new topics, and just like a follow-up on both a response to Jovo and to Masvita. And I hope Masvita doesn't leave us, because I want to ask one more thing before we move on to questions from her. But so Jovo, for neuroscience, it matters whether you go ahead and study just a neural circuit in one model animal, for instance, or you go ahead and study the interaction of a number of animals in an ecosystem. If you have a perspective like Masvita's, you're much more likely to not just stick to the neurons or neural circuits. So I think it has direct, or at least the way I understand her, what I read from her and what we've been discussing. Another thing is, if you're someone who is building AI and computational models of learning, and this is where this kind of answer to you connects to what Masvita was saying. She said very wonderfully that the bodies have material in common. They are made of metabolical cells, and the computational structures might not share that notion of life. I've thought about this a lot, Masvita, and how can AI revise itself in light of a comment like what Masvita said, which I think is very related to Paul's talk and his wonderful paper that we all appreciated as well. this idea of learning from a phylogenetic background and seeing what happened, the same way as this idea of understanding the notion of life and incorporating it in the idea of learning. I wonder, Masvita, what do you think about another framework of learning, which is computational, which is mathematical, but it does include metabolism, it does have a boundary and interaction with some ecology, and it has some sort of homeostasis. That's some kind of a learning framework that I'm working on computationally. I wonder whether you think that kind of moving towards that kind of a learning framework, which is homeostatic and ecological, would be closer, would hopefully bring computational approaches closer to what you consider life or cognition.
Yeah. Yeah, I mean, it sounds like it would do, and I look forward to hearing more about this project because I can't just comment too much without knowing the detail. Yeah, I mean, that's the kind of direction that would be suggested by what I'm saying.
So to answer Jovo, both in terms of the kinds of studies that we do, whether it's circuit or more embedded ecologically valid behavior, and in terms of the kinds of learning algorithms that we write computationally, I think this conversation is very pertinent. Also, with respect to what gets funded in terms of neuroscience, I think this is a pertinent conversation. What kind of philosophy do we have in mind with regard to functionalism? Okay, we have Flowers, and then we have Paul, and then we're going to go to questions.
So to Masvita's point, yeah, I agree. In animals have distinct kind of social organizations out of which the meaning of pain would emerge. So insofar as an animal understands what is painful, it does so through its own cultural transaction or its own transactions with the environment through its own cultures. And before somebody comes for me for saying animals have culture, yes, I am presupposing this, and I am making a broad assumption that an animal has a analog to culture through which it transacts with the world. Whether or not this analog of culture is, say, structurally similar to what humans understand as culture is up in the air, and we can extend this outwards broadly should we encounter, say, a non-human alien species, right? Would we be able to identify what they have as culture? So putting all of that away, to Masvita's question, yes, right? So the meaning of pain is dependent on the ways the animal is in nature through its own cultural embeddedness. That being said, to Jovo's question, so what this means for people doing work in the lab is that broadly, we should interrogate the broader contexts in which we are doing this work. That is, what question does your work seek to answer, and how does the answer to that question, once reincorporated into the broader vital activity of culture, transform human engagement with the world? So it is to ask what transformations in the world would be prompted by coming to understand consciousness as either mechanistic or as computational, or understanding the mechanisms of pain, which were some of the questions that came up in the chat. In my view, understanding the neurological mechanisms of pain would not necessarily help you resolve the social problems that accompany pain or accompany chronic pain, so on and so forth. You might be able to, say, remedy some of these issues insofar as, say, if you understand the neurological grounds of pain such that you could resolve chronic pain for some chronic pain sufferers, you would still have to address the broader social concerns that come with a chronic pain sufferer's embeddedness in society. So to that end, what I'm saying is we need to think of, or the value from my perspective is understanding the ways in which even the work we're doing in the lab is embedded in a social and cultural context and engages with the questions through that social and cultural context, right? It is not inevitable that we develop computational models of the mind, or that we come up with analogies that compare the mind, consciousness, brain to the computers. This is a product of our cultural inheritance and the ways that we engage with the questions through culture. So that's generally my upshot. But yeah.
Paul, you had something, right?
Yeah, my response to Jovo, which actually shares a lot with what Jonathan was saying, in my opinion, neuroscience theory, at least in systems neuroscience, is a bit, how to put it diplomatically, it's following the wrong questions, in my opinion. And it's not I think the mistakes are not in the levels of analyses and issues like functionalism. I think those are fine, but I think it's arrived at a series of assumptions about what the right questions to ask are, that were framed in the wrong context, in a context very much inherited from philosophical questions about, sort of rational human behavior. And then using that as the top level concepts to understand the lower levels and connect into a theory of how those things are implemented. And I think psychology and neuroscience are struggling with those concepts. I think those concepts are not mapping well across levels, despite their usefulness in everyday discussions that we have about the brain. The concept of pain is a very useful concept until you start, trying to break it down. And I just think that it's important that we are willing to look for different contexts. And I think the context that ethology and ecological psychology have is in some ways very promising. Not in everything. I certainly don't agree with all the viewpoints that those traditions have. Certainly not about the black box nature of things and not looking inside. I think that's incorrect. But I'm saying is that what we need, I think, in this field is to snap out of some of these assumptions. The computer metaphor is one of them. That really should have been dead 20 years ago. It's been breathed new life by the advances of new neural networks that aren't really solving the problems that it failed to solve, and they're just sort of making it look like it's not a big problem because we can label Google images. I think there are deep problems that people have been talking about for almost 100 years that have been largely ignored, and that we still have in psychology. And I think these other perspectives help us with those. Now, I don't know yet, though, because they haven't really been explored very far. I just think that they seem to me more promising because they're more, I think, compatible with a different context that's more biological, but also, at the level of I'm not saying biological in terms of neurons. I'm saying biological in terms of animal behavior, interacting with environment as well as other animals. All the levels.
So I think so people don't feel like they're losing the thread, and I actually think there is one here. Okay. And Masvita actually admitted when she was on that one of the reasons for her anti-functionalist position, and as she again articulated today, is related to the computer notion that Paul just mentioned.
Yeah.
She's not really that against maybe an octopus and a mammal or a marsupial mole and a golden mole. It's more the substrate-independent computer. And then you have Jonathan and Paul. And what you can summarize it as is, if you're going to get to cognition that isn't too computer-centric or too William James-centric, you're going to need to have a sensory motor system, a body, a life, a childhood, a culture, a sociality. So this argumentative style is out there, right? We need culture, we need sociality, we need a body, we need life, we need a childhood, we need to have gone through a sensory motor stage, either in one's life or in evolution, which Paul likes. Do not try and put the brain in a vat and have a computational, disembodied view of certain cognitive operations. Right? This is what this is all really about. Okay. And what I would say, and I completely agree that AI has come up empty-handed so far, right? So I don't disagree that we have to go and look at these other components that I just mentioned. But all that said, there is no other way of thinking about computation right now, cognition right now, that is, I think, useful without thinking it as computation over representations. Simple as that. Everything else just doesn't work, in my view. Everything else is up for grabs, I agree. Maybe you need a body, maybe you need to be alive, maybe you need a culture, maybe you need a childhood, who knows? But that simply fails as an alternative to the notion of computation over representations.
So could you get Amy, Jovo, first of all? Amy and Melanie, which means maybe we can say goodbye to flowers in the order that people were arriving on screen. Thank you so much for being with us the whole semester, and we hope that you arrive also, in spite of the fact that you're going to be teaching again next semester, we hope that you also have time to come here next year.
Yeah, I'll be here.
Awesome. So let's get Melanie and also Amy.
They're connecting and joining.
Which one is... So our top voted questions are Melanie Mitchell, Amy Christiansen, and Laurelyn. So maybe we can get the three of them, or at least two of them. So we get, hey! And also Amy. And then we have Laurelyn. And then there was a request for Adam Capex, which would be afterwards, after we have the highly voted women of the Salon. Okay, so maybe we can start with Melanie while we're waiting for others to join.
Okay, and just say thanks to Paul for coming to fit everybody else in.
Paul can stay on stage until we, have everybody else. So let's see, just in case somebody can show. Go ahead, Melanie.
Yes. So first, I wanted to say thanks so much for having this salon in general. I've enjoyed it so much, and it's just been such a highlight of all of what's going on this year. So my question was about what insights have we gotten for AI from neuroscience? And this is a general question I have, but also I'm part of a project called AI 100, which is a group of people over 100 years, although I won't be around that long, every 5 years writing about sort of what is the what has AI accomplished? And one of my assignments is to write about what insights we have gotten from AI, neuroscience. So I wanted to get your views about what do you think neuroscience has to say to AI, if anything? And what I just heard from John Krakauer is maybe nothing.
A lot.
I'm happy to opine. Is it my turn, Ida? So I think one thing that's obvious to me that biology has to say to AI is an existence proof, right? So, in a similar way to birds flying, like we know there are ways of building things that have the kinds of intelligence that we have. So the fact that we failed to build them is, it's not because it's impossible, but because we have failed. So as long as that's true, that's not a lot, but it's something. The next thing I think where it can provide, it can serve two roles. And there's a really nice paper by some of the DeepMind people a few years ago about the virtuous cycle. And they said, basically it provides two roles. So one is inspiration. So we can look at the behaviors and the underlying neural substrates to get inspiration about plausible behaviors and mechanisms. And the other is validation. And this is the one that John Krakauer really likes, which is once someone posits a plausible mechanism for solving a particular computational problem, we can check and look in the brain and see if that is in fact the mechanism that any particular organism is following. Does that answer your question?
Can we look in the brain? I mean, you know, what about like reinforcement learning? People, you know, there's some notion of reinforcement learning in the brain, but there's all these mechanisms that people oppose to get reinforcement learning to work in AI. And how can we look in the brain and see if they're there? Do we know enough about where to look?
I think it's a really fair question, and I think it depends on the degree to which the mechanism posited by the AI community is one that has like a biological realizability. So some of them, it may be really complicated to understand the mapping from the mathematics to the biology, but not necessarily all of them. And there's lots of examples for, you know, for backprop recently, where people trying to find like the neural substrate of backprop, and with varying degrees of success. So I think it can be done, and it's hard.
So I guess what I was asking was more along the lines of, you know, people in the AI feel like there needs to be some big new ideas in order to move the field forward. That, you know, we need to get common sense. We need to get, you know, robustness and the ability to generalize, but much better than what we have now. So does neuroscience give us any good new ideas that we can take and build systems with?
So, Melanie, when you say neuroscience, right, in other words, another thread from our whole Salon, right, has been, you know, do we go the way that the BBS article by Lake and Gershman, Tenenbaum, and others, where they basically said, look, here's the list of cognitive features that humans have, and we don't care how you implement them, but you're going to have them. Now that is neuroscience, that's cognitive neuroscience. That list and all those capacities and the computational theories underlying them is neuroscience, okay? So that paper is very useful for the AI world, in my view. Now, you can take the other thread, which is more the sort of Tony Zeder view, is why don't we actually get a little bit more implementational and have a look a little bit more at a model animal in neuroscience and have some reduced notion of cognition where we can actually get some kind of mapping between it and neural mechanism, and that we should use that kind of neuroscience to inform AI. And as Tony has said, you know, let's have a deep mouse first, right? Now, I don't think that's the way to go. I think the functionalist, computational, human attribute view is the way you're going to go if you're trying to reproduce common sense and all the things that we usually talk about in humans. So those are the two strands. My guess is that the second strand has not been that helpful, the Zadorian one so far, whereas the Lakean one has. Now, what's the way to reconcile those? Well, as I think I've talked about before, you know, somebody like a Nico Kriegerskorter and others will say, let's build a neural network model. Let's try and implement what Lake and friends are trying to do. And we may find that in order to get it, we're going to have to add to this very abstract neural network biological features. In other words, we're going to have to add a little bit more detail to this abstract neural network that we may get insights from by looking at cortex, for example. So that's one way that you could reconcile it, is go, well, let's add, you know, inhibitory interneurons, you know, let's add, and maybe all of a sudden, in an emergent way, you start getting extra properties in the AI.
Yeah.
Okay. But that has not happened.
Okay. So I mean, my view was that the Lake et al. Paper was, again, I agree, totally useful, really useful, but their list is a very high level list. It doesn't give any hints at how to accomplish these abilities that they want.
But
they have their own view, which is program synthesis and all of that stuff, Bayesian program synthesis. But what I didn't hear, I wouldn't call it what they've done neuroscience in the way I'm thinking of it, which is
Yeah, but I just think that that's just insulting to cognitive neuroscience and psychology, that doesn't count as neuroscience. It's again this idea that neuroscience is only if you can tell me what the neurons and their connectivity are doing.
Okay, but it doesn't give me any, their list doesn't give me insight into, it tells me what I should go for, but it doesn't really tell me any how that comes from ideas from.
So Ida, so I would say that the work of the kind that Ida and other people do, where you mix between AI and psychology and you come up with computational and algorithmic theories of what's going on, are very insightful. You see, I just don't think that those aren't providing lots and lots of insight in what's happening. For example, when you're imagining, navigating Toronto in a scanner, the idea that this isn't giving us insights because it's not giving us what neural property we have to reproduce, I just don't agree with that. I think there are two different ways of getting insight, and I think one has done better than the other so far.
I've been trying to raise my hand, trying to say it, and John even talked about my work, and I didn't get through something. So Melly, I really love your question. I have a couple of answers to it. There's a wonderful paper co-authored by Bengio, which is called Neural Networks Need a Prefrontal Cortex. There are a couple of situations where we figure out that some of the solutions to generalization that seems like humans are using might require us to learn something from the prefrontal cortex, for instance, which happens to be one of my favorite regions. Another thing is, for instance, things like neural SLAM and this sort of varieties of models that are based on simultaneous localization and mapping, being SLAM and varieties of them. It turns out they have a back and forth with the hippocampus. In fact, there was a recent paper in eLife by Paul Burgess's group, and then there is additions to the neural SLAM where it becomes, it learns from, for instance, they got inspired by, for instance, hippocampal reactions to navigation, and then they added semantics to it. So currently the semantically augmented neural SLAM not only is inspired by hippocampal approaches to navigation, but it's also inspired by the fact that we use semantics to infer which way to go in an apartment to, for instance, look for a spoon or where the bathroom might be. So it uses all of those things that it has learned before in order to use it. It also gets pre-trained on visual objects to dissociate them using visual sort of models in order to have that. So it seems like there is already in AI a very strong use or convergence on, first of all, this separation instead of end-to-end all the time, this separation of the vision part, the navigation part, maybe the generalization part. In the work that is done by, again, Bengio's lab, some of the interesting work where there is, for instance, transformers are being used to learn objects, they got very inspired by some cognitive science work from the 70s. Granted, this is not neuro, but then in sort of collaborations with them, I'm learning how much inspiration from neuroscience is actually helping them. For instance, how does a top-down attention work, or how does bottom-up work? They very meticulously look into stand the hands work, for instance. Another thing is some other kinds of work that, for instance, we are doing on a more theoretical side, which is, do we need to adjust our theory for learning, our learning framework and reinforcement learning, to have, for instance, to incorporate something like homeostasis in it, and then look at how different internal dimensions or needs to move and do many different things in the world. Things in the world don't come tagged with a tag of reward for us biological agents. We have some needs, we move around, some things seem to satisfy it and some things don't, we avoid, we approach, and that's how we are navigating. So another question that, for instance, I'm exploring with colleagues like Rob Shapire is whether we can figure out a kind of a new framework for learning, in fact, that is more biologically plausible potentially. And maybe this is going to be faster than reward maximization to solve certain even reinforcement learning problems. Maybe it's better for lifelong learning. Maybe it's better for, evolving, because interestingly, when we started the project, the title we gave our project was Evolving Pain. So how we evolve pain, hunger, and all these other internal things that help us to navigate the world in the longer run, it's going to increase our JT. Okay, Melanie disappeared. I think I bored her. Okay, that's all I had to say. I hope Melanie's still here and we just.
But Ida, I mean,
You see
that's
me?
all. But Ida, all of that's great, but you didn't mention neural mechanisms at all, right? And that's what Melanie wants. Melanie wants to know about neurons.
Oh, I mentioned prefrontal cortex function,
But
function, and that does relate to what we learned about place cells and grid cells, I have to say. So, go on, Melanie.
Yeah, can you see me? Can you see me?
no.
I can't see you, but I can hear you.
I can see you.
Let me try to toggle the video.
Jova, did you see her in your mind's eye or in your physical eye?
All three.
Can you see me now?
I can't see you, but maybe others can.
I don't know
I can
what's
see
wrong. I can see myself, but
That's okay. We
Okay,
can see you. Go ahead.
yeah. So John, I don't mean just neurons. I absolutely don't mean that. I mean,
You don't. As I said, we've learned tons from neuroscience.
what's that? Okay. I'll just say one more thing. One of the things that I've been thinking about is the idea of modularity and how much modularity in the brain seems to have a lot of modularity, which our AI systems often don't have. And one big question I have is what effect that kind of architecture has. There was that recent paper that talked about kind of the where, what pathways, and also the sort of social interaction pathway was really fascinating. And what would it mean for our systems to have more of that kind of modular architecture? So I'm hoping that I think there are many insights. I just curious to ask you all what you thought. So, and there's a lot of comments in the chat that I haven't been able to keep up with.
Yeah,
But,
I just think that there's a difference between a sort of neuropsychologically inflected computational decomposition of behavior into modules, which is what the neuropsychological tradition has been, which absolutely is hugely valuable because we know that modularity is how evolution works. Compartmentalize and specialize, right? That's what happens. So modularity, absolutely. And, modular decomposition, computational and algorithmically, I think we've learned a lot from the kind of work that Ida was talking about and others. What I was contrasting that with is the idea that there's going to be some canonical neural circuitry that's going to give us the insight. I think it's better to do it top down in the way that Ida was talking about, and then add neural details as they come along if they're required. But so far, I haven't seen that level of granularity being required.
okay, thank you.
I think Amy represents a nice middle ground between the two extremes you're proposing, John, which is on the one hand, Lake, who's all about human behavior, and Tony, who's all about non-human neural mechanism. And Amy sits in the middle. I think, Amy, you'll correct me if I'm wrong, but cares deeply about animal behavior and how that could be a more productive route to getting towards understanding artificial intelligence. So I wonder if Amy can comment on that. You're muted.
Sorry, I've never done this on a phone before, so I couldn't find the button. I think I've unmuted myself now. Awesome. I don't know about that necessarily, but I was thinking about this question, and yeah, I guess usually I'm like not that optimistic about how informative neuroscience can be for the progress of AI in general. Typically, I think actually just like answering questions just by sort of doing the experiment in a computational way is like at the place that we're at now, maybe more insightful than like looking at the neuroscience literature. But I think that there are some places in neuroscience where like sometimes when you read a paper, you're just like, that changed my mental model of like how I would ideally build a system if I was going to like try to do it tomorrow. So I was thinking about it, and I have one example of that, and unfortunately I can't remember the name of the paper, but there was a paper that came out a while ago, and it was looking at monkeys that were learning the random dots task and the drifting gratings task. It was a group in McGill, and they're basically the result was that if the monkeys had already learned the random dots task, then MT was necessary for doing the drifting gratings task. But if they hadn't learned the random dots task, then MT was not necessary for doing the drifting gratings task. So it's this really cool result that shows that like which brain regions the monkeys use to perform a computation is really dependent on the animal's previous experience, which is like, I mean, maybe not that surprising, but it really sort of shows us that the way that the brain does computations is super, super dynamic, and it's probably really efficient depending on like what brain region is going to be the most efficient at performing the computation. And I think it's something that we don't usually think about when we're like building networks. It's just like, you know, which area is going to most efficiently perform some computation. And so I think things like that, like looking at training order and looking at like where is information computed and like how can it be sort of dynamically routed. I guess that's an area of research that I find really fascinating.
Would you like to ask your top voted question as well?
Yeah, I can ask my question. So the question that I had was something I think is kind of, I'm interested in. If any of you guys have changed your opinion about anything from the conversations in the learning salon. And I guess I'll make it a little bit easier, as if you haven't like wholesale changed your opinion about something, if you can come up with an example of something that was like what was the thing that you spent the most time thinking about because of the conversations in the learning salon? Like what like kept you awake at night because of these conversations?
I mean, I feel like perhaps it's more, I had never articulated some of my thoughts or beliefs or frameworks this clearly, I guess, before the salon, especially with regards to the relationship between my philosophical background, the psychology background, the neuroscience, the AI background. I don't think whether these things already were inside there or not, I hadn't expressed them in this way next to each other. And I think that was one of the most valuable things that first came out of my conversations with John, where we started just a fantastic friendship when we just Zoomed sometimes and talked about things. And then after that in the salon, I guess that continued, and that became like a thing that I could pull together some ideas from different places. And specifically, this discussion with Masvita about like clarifying functionalism and just figuring out how much functionalism, anomalous monism, which is this idea that you don't have type identity between psychological and physical level, although every instance, every token is related. And the second, I can't read while I'm talking to you, sorry. So I'm just gonna not read your comment there. And another thing is this idea of thinking about a new learning framework. And I think that is maybe the most valuable thing that came out of this whole salon for me, which was a culmination of talking to everyone about different species, about the phylogenetic history of them, with Paul's talk, all the ways in which I differed or disagreed or whatnot. I realized I'm looking too closely. We are disagreeing about mice and humans. This is too close. This is not even an argument, you know? This is like mice, human, and monkeys. That's just too close to each other. And a couple of circuits about like controlled behavioral tasks. What? So honestly, as a result of the salon, I read more books that are about more species. I watched documentaries about more species. I started reading more about what can we, and especially after reading this kind of probably approximately correct, and this idea of pack learning and ecorhythms, this idea that we need to look at the ecosystems and the way that these solutions emerge to solve a particular problem of life, which requires metabolism, it requires protection of, you know, inner versus outer, and it requires reproduction. And then I realized, for instance, that bacteria, the same cluster of bacteria can live for millions of years. obviously we are not the pinnacle of evolution. Like we are not, you know. And also, I think I started rethinking my ideas of evolutionary fitness. Some 19th century idea of evolutionary fitness that I think is kind of prevalent, and I think it's damaging to nature, is this strange idea that everything that we do is towards preservation, is towards having offspring and preservation of our lineage, and that's it. And I think this is very short-sighted, and that's not how to look at it. If you look at nature, so many species are living together that should be killing each other, but they're not. Like birds go inside crocodiles and they clean their teeth. Like, why would you ever, if you're so small, why would you ever go inside the mouth of a predator to eat your food? Why would you not eat it if you're a predator? The symbiosis that happens in nature all the time. The ecologies that sort of grow together and sustain over 4.5 billion years. Yesterday, we were talking to an astronaut for the holiday event at Microsoft Research, Chris Hadfield, and I asked him how his relationship to Earth changed as a function of going around it so much and looking at it. He said he doesn't see it the same way anymore. And he said that he can see the scars and the age after going around it so much. It's 4.5 billion years. That's like not imaginable. That number is not imaginable. We're so young compared to our species. And that ecosystem is going to regenerate after we destroy it, unless we really blow up the planet. We're gonna, at some point, end. But I think I became a lot more attuned as a function of also having a lot of plants during the pandemic. That was my baking. Instead of baking, I just had a lot of plants and grew my salad in the kitchen with artificial lights. I feel like I became a lot more interested in learning for algorithms and for computational purposes from anything and everything in nature a little bit, and not being so bound in a 19th century style to one species, to looking at one thing or focusing on dedicating your whole life to one thing. At the same time, I'm creating like AI in games and testing them to see whether they do human-like behavior. So this thing that we're writing, a navigation Turing test. So you do some things that are very based on AI that has human behavior, but also this idea of, if we want good algorithms, if we want intelligence, we need to look beyond just what I can do or what a mouse can do or a C. elegans can do. We need to look at the relationships, interactions that shape learning in ecosystems. And at least that's how I think that was the biggest transformation that I intellectually experienced. And I'm going to stop talking because I talked a lot. Sorry.
Actually, yeah, Amy, I wanted to just tell you, I don't know if you know this psychologist, her name is Merav Ahisar in Israel, who's done this wonderful work. It's about 20 years old now, called Reverse Hierarchies, where she talks exactly about, it's beautiful actually. It's about, if you have a task, you hierarchically assign solving of the task to the component of your nervous system that can get away with it without having to get down to the nitty-gritty tuning of particular neurons. So it's actually, you should look at that work. It's actually hugely inspirational to me, and it's deep what she did in that work. So Merav Ahisar, M-E-R-A-V, and then A-H-I-S-S-A-R. And it was a paper called Reverse Hierarchy in Sensory something or other. It's been a long time. Okay. To your question about have I changed my mind? Not really, right? I would say that if it were just a salon about psychology and neuroscience, I would say, taking the David Bohm view from physics, that there is no privilege level. There are many ways to chunk the world, and there's no privileged way to chunk the world. And that there's never going to be a perfect alignment between the neural circuit and the psychological object. Okay. So there, I'm actually more certain of that than I have ever been. Okay. On the other hand, where I find myself genuinely puzzled and challenged is if we're going to try and make common sense in a machine, then by definition, we're going to have to build it, right? So there's going to have to be, at some level, an alignment between how we actually build the bloody thing and it having common sense, right? So in a way, my willingness to live with psychology as a wave and neuroscience as a particle, and they're just different ways of explaining the same phenomena, and that, you know, as Carl Cravers recently called it, he calls it pluralistic preservationism, right? I'm fine with that. The disciplines exist separately because they're ontologically real, right? Economics is never going to turn into neuroscience, right? They can help each other sometimes. But AI gives me a headache, because at some point, if you are a functionalist, we're going to have to be able to have a machine with common sense, unless they have to have a body and a childhood and a lifetime and a culture and sociality. And therefore, that means the one thing I've learned from this salon is there's something vast that's missing. Something vast. We just don't know how to do semantics and common sense and stuff like that. But if we're going to believe that a machine ultimately can do it, then what on earth are we missing, right? And so the comfort of just letting psychology and neuroscience live in parallel and do their own work with their own vocabularies and their own concepts doesn't rest well with me, because we're going to try and come up with a machine, right? And that does disturb me and keeps me up, because we're going to have to reconcile somehow and come up with some way to do it. And I just don't know what it is. It just feels like there's something we have yet to discover that we're missing. And that's where I've become more profoundly uncomfortable, is that you'd like to, as you know, put yourself in a cryo chamber and come back in 100, 200 years time and go, what was it that we were missing? You know, that's
John,
what I've learned.
John, I'm very glad that you said that. First of all, I do think you're beginning to change your mind about just what learning in machines means, because I feel like we had a lot of rounds of conversations, you and me, even before the salon about this. So I do feel like you've changed a little bit on that, if I may say. But to your other point about common sense and when are we going to have that common sense, I think, again, and I can't believe I keep bringing this up. First I said metaphysics of mathematics, now I'm going to say history of mathematics. I think looking at the history of mathematics is extremely helpful. When math started to become formalized, and before that, people were still using actually pretty challenging formalisms in architecture, but then they were preserving it or passing it on with words or with weights in poetry. There were so many ways people were doing it before we had formal equations. Once we finally moved from poetic descriptions of equations to actual equations, then there were theorems that were left unproven. And then every now and then, there was a time where the progress was fast and it was slow. Some things weren't proven for another 100 years, for 200 years, some things weren't proven. Somebody would find it. A lot of the people who would solve something that hadn't been proved for a while, they would just drop dead early. That was very strange, which was something that I keep like looking at the history of math and I'm like, what are all these young deaths? Should I make sure not to do too much math? Like, that was something I was thinking about when I was younger. But if you look at the history of math, there were things that people didn't have the imagination 300 years ago, 500 years ago for. And now they have the mathematical imagination to actually, or formalism if we can't visualize it. And by imagination, I don't just mean visualize it, but something that with equation you can imagine, something that there is some language. If it's not language of mental images, it's not a verbal language of symbols of natural language, it is the language of math. To be able to imagine certain ideas at all is a huge step that we have taken. And the way that I see it, I think the difference between you and me and the difference between this discomfort is that I see it as we have a couple of math problems to solve, maybe a couple hundred math problems to solve. That's how I see the problem. And also these couple of hundred math problems, some of them need to be fit to human behavior and to other species, and we need to learn to build the right environment. But it seems to me like we're just like getting there, but yes, are we missing some things we might not have? Yes, definitely. Do I think they're never going to happen? As long as we don't destroy the earth before we come up with the solutions, I think people are going to figure it out. Either they're in the 27-year-old club or they are in the, in the sustainable life club. Either way, I think I see it as yes, it's not going to be one equation that's going to solve everything. I don't believe in this kind of math genius ideas at all. I think there's going to be some interdisciplinary collaborations to even formalize what the problems are, and then coming up with them, and then using those little modules that we didn't know to put it together and solve the problem. And I don't think it's out of reach as you think, or discomforting. And I'm going to pass the baton to whoever next wants to talk.
So I can say what I've learned. I think it complements nicely actually what Ida was saying, in the sense of, so Ida held up the book by Valiant, and probably almost correct. That's like kind of my bread and butter. I've been thinking about estimation theory for 10 years, spanning all the way back to Glavenko-Cantelli in the early 1900s, and then Vapnik and everything else. And so, but what I didn't care at all about until the Salon was reinforcement learning. For me, the fundamental questions were about estimation, and it didn't really require interacting with the world. And I think through these conversations, I've decided that those things are only partially true, in the sense that if we're going to get a good explanation of intelligence, it will have to be a one that is inactive and engaging with the world. And it will require notions of something like causality or reinforcement learning or something else that really hadn't been in the conceptual repertoire of things that I thought would be required. And I still have no idea what that means, just so we're on the same page. Like, I don't get causality or reinforcement learning at all, but I do feel like I will need to understand them in order to make meaningful progress. And the field of AI and statistical estimation and causal inference and reinforcement learning will need to converge together more effectively to make progress. Because I think that's a big problem with the field. Just to get a little bit more concrete on the other side of what Melanie was saying, there's other things that AI needs to do to make progress, not just things that biology needs to do. And I think one of the big ones is get a better handle on the relationship between reinforcement learning, causal learning, causal structure learning, causal estimation, and statistical learning.
I guess we're down to Laura Lynn now, and then Adam Kepex was requested to be online. So at some point, maybe we can invite her. Laura Lynn, go ahead.
So hi, thanks for having me again. I'm a postdoc at the Center for Theoretical Neuroscience at Columbia. And yeah, what I wanted to ask is related to the fact that I feel that there is a great discussion going on here about the many limitations of the field today, and how it's very useful to have many different perspectives, how it's hard to think both about function and about circuitry. But for me, when I look at recent papers, I get hopeful for a few of them, not most of them, but a few. It could be because I'm more naive to the field, I don't know. But so I was wondering for you if you have particular papers, particular new works that you think are more promising, maybe more innovative. Yes.
Melanie, do you want to take up that question? You're still muted for some reason.
Sorry. I'm sorry. Can you repeat the question? There was some distracting stuff going on in my background.
Sure. So it would be, what type of new approaches, new work do you think you've seen recently that concretely you think made a difference, were more innovative, and are starting to address the challenges of bringing function with more circuit implementation, inductive bias, that type of constraints? Yes.
Do you mean in artificial intelligence?
I guess both in artificial intelligence bringing more constraints, and in neuroscience bringing more function, more towards intelligent behavior. So basically, what is new and promising that falls into the theme of the salon?
I think there's a lot of really interesting things going on in AI. I'm less of an expert on neuroscience, but I don't know I don't know how promising they are. So this whole area of transformers and self-supervised learning, I don't know if you're very familiar with this, like GPT-3 and all of that stuff. It's fascinating to me how well these systems can appear to do things that we never thought they could do. Learn from very few examples and so on. But they're doing it's doing it in a way that seems to, not capture this thing that John Krakauer was talking about, which is sort of, this vast gap between humans and AI systems, is semantics, understanding and so on. So the question that comes up is how can we more usefully articulate what it is that we want that these systems don't have. So it's not like that, this, to me, that's how we're going to make progress in this field, is by being confronted with systems that have some of the properties that we're trying to get at, but trying to articulate sort of what's missing. Because I think, when John Krakauer says, that there's a vast amount of stuff that's missing in AI, and this makes him very uncomfortable. How do we actually articulate what that is? Sort of what is this common sense thing you speak of? What are we really talking about? And to me, the way forward is to be confronted with actual examples of people trying to address this, and then trying to understand what's missing. So I find that really interesting. I think a lot of the work on reinforcement learning that's been coming out over the last several years, and combining reinforcement learning with sort of more symbolic architectures is really interesting and promising. But I do think that I agree with John, there's something that we're missing here that nobody knows even how to articulate what it is and how to approach it.
I think my favorite work that's come out in the last, say, year or so on this topic is really people have been pushing the combination of things about causal inference and causal estimation with machine learning, because those fields have been unnecessarily divergent in my view. And there's this beautiful book written, it's not out yet, but by Miguel Hernan called What If? It does such a great job just explaining causal inference from both conceptual and statistical perspective. And I think it's that kind of thing where we need to understand, like, what Melanie was talking about. Causality is one of the things that machines are still pretty bad at relative to us, it seems. And there's a small subset of the community in AI who's working on it, and a large subset could be working on it, but there's a bit of a language barrier that's unnecessary. So people who are able to bridge those kinds of gaps, I've found that work really valuable. John read nothing he liked this year.
Oh, books? I was knocked out, remember? So is that what we're talking about, our favorite books?
No, I think Laurelyn's question was that what kind of paper, either in neuroscience or AI or book or whatever you've read recently, makes you hopeful, or you're inspired by, you think it's a way forward?
No, I feel a little, I like the line by Kafka. There's hope, just not for us. I just, I think I agree with Melanie. I think that we need to feel a little bit more certain about what it is that this thing is, and at least know what our target is. I'm a lot more sympathetic. You know, Melanie is very funny in her book and has whole sections about common sense and that famous photograph of Obama putting his foot on the scale. And I think we know what it is. It's like I've said on this salon before. It's the fact that we can laugh at New Yorker cartoons, and you know, Instagram has the top 20 New Yorker cartoons. I mean, we all know it. We're all using whatever this mysterious gap is in this salon for the last 2 hours and 15 minutes. In other words, we may not be able to formalize it. We may not be able to put a pin through the butterfly, but this is not, AI are not having learning salons anytime soon, right? So the question is how does one put a pin through the butterfly of understanding New Yorker cartoons? I haven't the slightest idea, right? We still don't know how you reached up to pick up a glass of water, right? I mean, we still don't know how that works. So I feel, you know, I think Ida's right that we haven't been on this earth very long, and if we don't outstay our welcome, maybe we'll work it out. But I don't think we should be embarrassed right now that we don't even have a fuzzy idea about how we're going to do this.
If I can say something quickly here. So I'm just trying to understand what makes you unhappy with any progress that's lower levels than the New Yorker cartoon understanding. Because it seems to me that, as you were saying, like, we don't know how we grasp, you know, an object right now. But it seems to me that for these very basic level skills, vision, motor systems, there has been qualitative changes, including some of the little magic, as in, to me, magic is out of distribution generalization. How do your network still works beyond qualitatively what you've shown the network during learning? And I think it looks to me that this is kind of coming along. You know, the vision work for me, I really like the work by Jim DiCarlo recently with the attention work, putting back some neural constraints on attention. I'm not going to talk about the motor control because it's me. But yeah, could you explain why that's not hopeful to you?
I just want to say one thing before John responds or someone else. I think something that really has been on my mind for a long time is how to tell some neuroscientists that all cognition is not vision. Vision is not a model of all cognition. And I actually had a recent panel with Dan Yamins and others, and I was surprised that I have to actually argue this point, as opposed to this being obvious that vision is not a model for all of the brain. It's not a model for all of cognition. So I think that I do not agree, and I am disheartened by the optimism that if we study vision long enough or hard enough, then we're going to solve the entire brain, and all of the grants going there and all the bright grad students for a long time going there. Jovos is especially in mice. So that's something that I just wanted to add. That's part of the reason I don't get too excited about much in vision. First of all, it's like one of the oldest. So I don't know. It's just not, I don't know. There's a lot we've learned from it. There's a lot more to learn from it, but it's not enough. We have to really look elsewhere. It's not, and we can't wait to finish vision and then move on. So I think that mentality sometimes is something that bothers me. One thing I did want to say to John is that, in fact, we did write we have a paper sample where we have different agents with different word embeddings. And we have a principle for spread of activation of memories and plasticity of changing it. And we just let these agents talk to each other, first in dyads and then in different networks. And then we observed how their memories got more similar, convergent, or more separate from each other. And based on the graph structure of these agents that were talking to each other, whose memories would get closer or further. So I think that was like a Salon version for agents, at least, that I can talk about. And I've often thought about what would happen if I had trained each of these agents on a different philosophical tradition. So I had these agents with word embeddings from different philosophical traditions talk to each other in different network structures and see what come out. I just wanted to say this as a playful response to when you were saying that AI doesn't have salons. Granted, we had organized it, so the same people who organized the human salon were organizing the agent salon. But all I'm trying to say is, and also this is what I wanted to also add, Natasha Jacques has this work she did, beautiful work that she did, where agents, in order to coordinate with each other towards goals, they started developing this scheme where they were communicating with each other. And the ones who were giving more accurate information started to gain more influence in the social structure of those agents. All of this is in DeepNet. So I would say that Natasha Jacques definitely showed this situation where reinforcement learning agents evolved, deep learning agents, they evolved this communication and even a notion of influence if you were saying things that were more interesting or more relevant to others. So I will leave that paper also in the chat because I think that relates to what you were saying earlier.
Laurelyn, what I would say is, I think at some point Zena in the chat said, maybe, John, you should just not be fine with pluralism and understanding, but you could still have implementation succeed, right? All I would say is that if we do begin to do what Ida's saying and you end up generating these things, my feeling is you're just going to be back to pluralistic understanding, is that you're just going to say, well, this machine has evolved with a little bit of tweaking by humans, and we're right back where we started, which is we're going to have multiple levels of understanding how this machine is doing it, and we'll still have different vocabularies depending on what we want to talk about when it comes to that machine. I just don't think it's going to be, I just don't think there's going to be a sentence uttered to a human where you go, yeah, that would lead to semantics, right? I just don't think it's going to be that, yeah, I get it. That's my deep concern. Do you see what I'm saying? I just don't, we're not going to have that feeling of, yes, of course, right? That's what I worry about.
I think there's a parallel worry that I fear. That is, there's a reasonably strong argument that you could make that many of the advances in AI over the last 7 years are essentially because we got bigger computers, and they could store more data and do more computing. And the ideas have not actually been that transformative, but the size of the computer has. And if that has been the driving force, then we're in big trouble, because that has been an exponentially increasing curve, and we're about to hit a wall or have already, in which case we need something dramatically different to come up with to make more progress. And I'm not saying it's true, but I'm saying there have been exponential gains in computing, and there haven't really been exponential gains in abilities. So
how do you measure gains in abilities? We know how to measure gains in computing. How do you measure quantitatively gain exponential or non-exponential gains in abilities?
well, you can look at like the error rates on ImageNet, and it goes like this on a line over time, whereas the computing goes like this.
I don't think ImageNet error rates on ImageNet is a good measure of abilities. ImageNet's a very weird data set.
I think at best it's very generous to AI to say, ImageNet getting better linearly is very kind to AI. I'd say it's not even that good, and even then it's still linear.
I agree with you, but I'm just worried about this notion of measuring improvement on abilities, and that's something I think people in AI struggle with. Is how do we actually measure how well we're doing?
Well, John and I and others have recently been proposing that we want to build benchmarks that are more appropriate, ecologically appropriate. So like, can we build an AI that's as smart as a honeybee, or one that's as smart as a crow, and set up the situation and the challenges that are similar to those that the honeybee or the crow faces? This is possibly related to Ida's new learning theory, where if it's going to be as smart as a crow, maybe it needs to have the same kind of constraints as a crow, and maybe need to maintain homeostatic equilibrium or other things like that.
Have you seen this?
Very well. I'm not working with you on that, so let's keep the boundaries of those things.
There's a benchmark out there called the AI Olympics, which tries to do exactly that. So you might take a look at that.
Cool.
I'm actually going to have to go. I mean, this is absolutely fabulous, but I actually have an obligation, and it's really difficult. I just want to thank all the guests, and especially the honorary, basically founders like Melanie, right? And this is fantastic. We'll be back next year, and it's actually kind of been an honor to co-host and to have the team in the chat as well, with Eva and Kanika and Brad. But I hope no one's too appalled by my saying that I haven't changed my mind about anything. That's not completely true. I saw that Adrian went in big capital letters. I knew you were going to say that, John, so I'm feeling a bit guilty, but what can I say? All right, big hugs, everyone. Bye.
Bye, John.
Bye.
Wait, so I just have one
I just want to
question.
say that we can now invite Adam now that John is off. So while Amy's asking her question.
Yay. Yeah, my phone is gonna die in like probably 1 minute. So if I disappear, then you'll know what happened. So I totally I totally agree about this idea that like we need to do a better job of quantifying what it is that we're missing in AI and like what it is to be smart in AI and how do we measure that and what do we mean when we say that animals are smart or animals have common sense. And this kind of ties back in to what my answer to my question would have been. And this is kind of, I wanted to say this because I think it's interesting. Something that I've been thinking about a lot is like, I tend to say, if I think what makes an animal smart, what makes my lab rat smart is that they're not domain specific. They have a lot of like, they're not like just good at nose poking. They have a lot of ability, they can run around their cages, they can sort of run around the floor, they can do a lot of different things. And Ida's comment kind of reminded me of this because while they're quite general, they are general within some ecological niche that they've evolved in. And it's interesting because we say they're smart because they're generalists, but also we have to consider the ecological niche that they've evolved in. I think that there's this like trade-off between every species has an evolved niche, and humans just happen to have the evolved niche of the whole world. That's their like AI set. It's the whole world. And so when we're asking the question of like how smart is an animal or how smart is some species or how smart we want AI to be, like we want them to be general, but we also want to consider the niche that they were evolved in. And I kind of wonder, like, is it a fair, I guess my question is it a fair question to ask, like, these other random animals that you've been thinking about, Ida, like maybe some penguin that's raised in the Galapagos, like, if you're asking how smart that penguin is it a fair test to ask it to, like, try to pick up paper clips in New York? Like, is that a fair test of common sense of that animal, or is that sort of like a domain? Have you gone outside of the domain of that animal? And if you have gone outside of the domain of that animal, then like how is that animal any different than a reinforcement learning algorithm that's only been trained on the tasks in some set of tasks that we're complaining about? So that's something I've been kind of thinking about a lot, and I wonder if maybe the world of animals is quite a lot larger than the world that we train reinforcement learning algorithms on, but it's actually not so different. So yeah, it's
Yeah.
Hi, Adam.
Hi.
Office.
Thank you for asking that, Amy. I really like that question. So what you said, that some generalizations are generalizable in an ecological niche, and we need to consider that, is extremely important. Something that I don't like in the Animal Olympics testbed and in any kind of benchmark, here's a bunch of tasks, here's a list of tasks, and here's the benchmark for bee intelligence, for instance, that Jova was talking about. Something that I don't like about these approaches is indeed the limitations of the tasks at hand. Are there really a set sort of list of tasks that are going to capture B intelligence. I don't think so. But I do think that while benchmark is not the way, I think the benchmark setting is not the way to go. It could be that some other people are going to sort of argue that, yes, benchmark setting is the way to go, and we just need like a list of tasks, and if it's the right task, then we'll get there. I do think we need to develop something with an understanding of with the phylogenetic background of these animals a little bit, but not necessarily just genetic or neural circuit level. That's not what I have in mind. But actually, what kind of niches did they develop out of? And then secondly, maybe something more than just something that's more open-ended than a couple of benchmarks is going to give us their kind of things. And I 100% agree with you that picking up paper clips in New York is not the way to test penguin intelligence or whale intelligence or even monkey intelligence. I totally agree with that. Maybe monkey intelligence because they're closer to us, but like definitely the fine grainedness of our fingers, it's just really not necessary. If you have hooves, you can still be intelligent, but not be able to ever pick up a paperclip, right? So what I do like about what you said is thinking about the ecological niche in which certain generalizations make sense. And I do think looking across species and looking with a quote unquote functionalist perspective at what is in common in some of those ecological solutions might actually get us closer rather than thinking about benchmark tasks. So not benchmark tasks, but a sense of the kinds of problems, ecological problems maybe, that there might be many different tasks involved in it, and you just define it on the basis of an environment and having some kind of a defined agent to sort of manage there. I wonder whether Melanie wants to say something. She came closer to the camera. So.
Sorry, can you hear me? Yeah. Yeah. I mean, I agree with what you said, Ida. I think that, and someone in the chat pointed out that this is a problem for in psychology, animal cognition. People do tasks in the lab that are not ecologically appropriate for animals, that really don't tell us anything about their intelligence except in some human defined notion of intelligence. So I totally agree. And there's a comment from Blaze, Adrian's husband, that I was just replying to you when you were talking to, which said we should take into account the social aspect of intelligence, which is incredibly important, but it's extremely variable among different species. You know, some species are extremely social, like humans, or ants or bees. Some species are hardly social at all, and that has to be taken into account as well. So I think you're right.
I agree, and I think the paper that I referenced like above that I can't even find anymore, so I will just put it again. Intrinsic social motivation via causal influence in multi-agent reinforcement learning. That's a paper that I had sent, and I'm pasting it again. I do think the beautiful paper by Natasha Jacques goes into this social aspect, and thank you for that. Okay, I leave the floor to probably Adam if nobody else wants to comment on that. Go ahead, Adam.
Hi, can you hear? So first, I should say that I think the most exciting part of this salon is really bringing this conversation together. So I feel like I've certainly learned a tremendous amount, really. And the only person I really disagree with is John, who just left, because as an MD, he just doesn't take neuroscience seriously. And we keep coming back to this issue that what have we learned from brains? And I think you probably have a lot of neuroscientists in the audience. So I think it would be nice to have those kind of discussions of what it means to learn from neuroscience, because it feels funny to expect some exciting knowledge from synapses to just suddenly change how we view cognition, of course, and then resort to cognitive exceptionalism of us as a species because we are not learning from synapses, right? So it's like a mixing up levels issue. And I thought there was a huge missed opportunity in the early in this conversation about pain, because pain is actually a pragmatic issue in neuroscience today. And the NIH had some RFAs trying to fund new ways of quantifying pain in animal models, because there's just an urgent need to actually have the behaviorist insights translated into some sort of model, so that we can actually make progress on the neuroscience of pain, which I think will actually have a societal influence. And this is a place where really there's an opportunity for behaviorists. I mean, this is further away from AI, but fundamentally about something that's really basic to us. We were discussing, Ida, you were saying about pain as one of the foundational things, even for other animals. For any pretty much any organism, presumably in some ways. I think it's a huge opportunity for making connections, where neuroscience is not giving us the answer, but not because we don't know how to do the neuroscience of it, but because we don't know exactly what it means that at that moment this animal is in pain. And the broader point here is, I think the brain is more than just an existence proof that AI exists. I think we can actually, which is how it's been looked at. I hope we can really learn from brains, and I think we can have a real impact also on society if we solve a lot of issues in neuroscience, where AI could actually come and help. That's kind of what I have to say.
Sorry, when you say behaviorists, do you mean people who do behavioral experiments, or are you talking about somebody so accepting the idea of behaviorism, like Skinner, etc.?
No. I just meant people like John, and people who find the behavioral level the most compelling. That's all I'm saying. That there's a lot of discussion at that level, and again, there's an urgent need for that level to have an impact on this particular topic.
Right. So for instance, Tolman, who was he was anti-behaviorist and the initializer of the cognitivist tradition. He only mean that. What's that?
I don't mean that debate, but yeah, I didn't mean behaviorism in that sense.
Right. I just want to clarify this, that John is definitely not behaviorist. He's because that's the meaning of behaviorism. And in fact, Tolman, who was against behaviorism, only did behavioral experiments, only needed one behavioral experiment to show that, and that was the latent learning, right? So I think that behavioral experiments can do a lot without being behaviorist. I saw that on Twitter. That's why I wanted to mention this. I saw somebody else did do this on Twitter, and it's a dangerous move because we could let in behaviorism through the back door. But go ahead. Anybody else wants to?
Maybe we should wrap up at 6:30.
Yeah, it's been a very exciting session. Honestly, I could not follow the chat. At some point, I realized that I can either do this or that. And it's kind of sad because I feel like there were so many exciting things. So afterwards, we're going to get the CSV of the chat so I can just see what even happened. It's been so awesome to have everyone here. Maybe one last thing before we leave, because Adam arrived so late. What do you think that AI could learn from neuroscience that we might have missed in the things that we covered? Because you might be the most neuroscientist of us all.
I mean, if you just want to use it as a pragmatic thing, I think we're missing cell types. I certainly think we're missing a foundational thing. Well, it's a foundational thing in biology that's not really, there's really not really a translation to any of our abstract models because we think it's just an implementation detail. But I also think that this is not necessarily exactly the way to learn, that we're going to have one little piece that we're going to learn from neuroscience and suddenly we're going to understand a new algorithm. But rather take the implementation level seriously for its own sake and actually sort of get a sense about the solutions and the solution space. And again, move away from cognitive exceptionalism for what sort of organisms can do in the lab, which is, I think, what a lot of neuroscience is studying. And I think there's a lot of sort of negative opinions expressed on what we're doing in labs. So in that sense, or what animals do in the labs. and we're able to do with them. I think a lot more open mind there would probably actually help AI.
Hey, Adam,
To be clear, I just want to respond to that. So we're not saying that what people are doing in the labs is not helpful. I personally have ran a lot of controlled experiments with humans in the lab, and that's not exactly natural habitat. Well, it is by this point, but it's not what we evolved to do, be in front of a screen and press buttons. But I think the point was that there's not enough of the other side. So saying there is an absence of something else is not to say what is there shouldn't be, right? We are not saying that everything about the current approach is wrong. We're saying something is missing. The same way that in AI, a lot of the times AI is a solution to a problem. You don't want your Roomba to also, have feelings or something. It could just like destroy your carpet. You want some AI is really made for one purpose. And so learning the kinds of networks that enable that one thing. Some AI is just for vision. So just learning from vision is enough for it. It really doesn't need to know how to grasp an object, for instance, right? Another AI needs to grasp an object. It really doesn't need to know how to use language, for instance. So there's purpose sort of goal-directed Roomba AI, and then there is other ideas like generalization. I think what Amy was saying is in the category of how far can we expect generalization first, and second, are the kinds of tasks that we have in the lab, is it possible that we're missing aspects of intelligence in the animals that the lab didn't, or at least that's how I understood the question. And that's what I took from the question and responded to. So I think we shouldn't I hope that nobody who's watching this and who's a neuroscientist, I hope nobody thinks that what we're saying is that lab neuroscience is useless or vision is useless. What we're saying is that there is an imbalance in how much in our ecosystem we have other types of work. That's all I'm saying. I just want to make sure nobody thinks I'm saying that their work is not helpful.
John is saying a little bit, but I agree with you that neuroscience could do more with behavior and cognition.
Amy, go ahead.
I think the thing about cell types being the missing thing is, I don't know if we have enough time to like talk about this. You can feel free to stop this topic of conversation, but I think I wanted to push back on that actually. So does that presuppose that there's like a mapping? Does that presuppose a mapping between like neurons in the brain and units in AI algorithms? And if it doesn't, then like, what is it exactly that's missing from AI algorithms? And why can't you learn? I guess this comes back to actually a topic that we've talked about a lot in the Learning Salon, right? Which is like, how much do you want to learn versus what should you bake in? And I guess you really could learn from neuron soup kind of anything if you assume that there's not a one-to-one mapping, right? If you assume that some like piece of neuron soup could learn to perform whatever the functional differences that the cell types had were, you could learn that. And so then the question is like, what priors do you think cell types are giving the brain? And do you think that that's, I guess that's really the question, is like what priors then would be, or sure, cell types would then be like an architectural prior. And what do you think they're for?
The question is not that the ultimate answer to cognition is cell types. It's not the point. The point is what should be learning from neuroscience? And given that we don't know how, we sort of, that was a lot of the conversation right in the chat, that we don't even know how to define attention after all these years, and there's all these foundational issues about cognition. We should take the implementation truly seriously. Sort of, if you know that the kidney is one of the main functions, it's filtering. You don't need to know actually the podocytes and all the different implementational details. But if you didn't know that, you might actually learn something from approaching it at a cell type level. And the same way in neuroscience, if you had the answer from a different level that we just know exactly what it remains, then you can just deal with it as implementation level. And I feel like it's just a mistake to not take seriously the nitty-gritty in neuroscience and actually try to learn from that. Of course, the ultimate answer should not be cell types, but why ignore something that's really fundamental to biology and has helped every field of biology?
Well, if you can capture it with an algorithm that distinguishes between, for instance, there's different architectures for CA1, CA3, dentate gyrus, entorhinal cortex, and then prefrontal cortex, and other different subdivisions of prefrontal cortex. If their algorithmic role that they're playing is capturable with one cell type, but with algorithm, one can get the function. There's no need for, there's no need for that level of implementation to come in play necessarily. Unless someone can show mathematically that it would be more efficient computationally to have different cells.
Just when you want to wrap up, you're opening this up. You asked me what should we learn, what should AI learn from neuroscience, and that was my answer to that. The question is, of course, not that the fundamental answer is, do we have to do everything with cell types, or will cognitive questions be answered? Of course not. But if you really want to take seriously how the brain does it, I think this is one of the thing that's sort of so striking dichotomy in our entire field. If you look at the Brain Initiative, a lot of the effort went into trying to define what a cell type is in the brain, categorizing them, and there's entire institutes to this. We don't have the answer, of course. And then sort of, as we're trying to use neuroscience to sort of in the AI direction and think about that, then we're just kind of dropping that. I feel like there has to be a bridge between the two. And then ultimately we can throw it away. But right now it's a huge missing gap.
I see what you're saying. And I think I want to read Adrian's comment. Adrian Fairhill in the comments, she says, this speaks again to what dynamics is contributed by biological and biophysical mechanisms. For instance, interaction of neuromodulation with cell types, and these would be chemical connectomes. And I can see that point. I do still think functionally this could translate to different architecture, but I haven't tested this empirically, so I don't know, or theoretically analyze this. So it would be interesting to see whether having these different types of cell types, even if you can show that the same thing that a neural network actually can solve, a deep neural network architecture, even with a complex architecture we have now, or a simple one, if we can show that the amount of computation is reduced if we use multiple cell types, I think that would be a huge advance forward, where we would have taken inspiration from cell types or implementation level and brought it to improve the computational efficiency. I think that if there is someone who can do that kind of work, that would really kind of move things forward. Adrian also says there might be incredibly more powerful and effective algorithms that can be implemented through these biological dynamics. Right? That's what I totally agree. And she also says that Blaise says, and more broadly, evolution took billions of years to learn to learn. In AI, we approach this with meta-learning. Yes, and which is exactly the kind of approach that we're using together with Rob Shapire for evolving value. Not enough on evolutionary timescale. That's right. And then Melanie says, deep learning took the idea of hierarchy from brains. This is a very interesting conversation. Now I just want to read the chat. Melanie, do you want to speak up yourself?
Yeah, I mean, this is something that I think, it's just an example of an important insight that came from the brain. It's this idea of hierarchical structure, and that's really been one of what's at the success of deep learning. A neural network that has enough hidden units, a single layer, can do anything that a deep neural network can, but it can't do it as efficiently. It can't learn it as well, as efficiently. And that's a really important idea that I think came from the brain.
I want to give Jovo time to say something. He has been quiet for a long time and looks a little worried.
I'm not that worried. I think what Adam's saying is very interesting with the cell types, and it has been ignored. And it would be cool if someone could do what I did, saying prove that there's some computational efficiency or data efficiency via having some kind of categorization of units. However, whether the mapping, as Amy was saying, was from neurons to units or layers or capsules or whatever the thing is, that would be interesting.
I think this is a very fortunate place to sort of end this, and maybe at some point some of us can collaborate together to figure out whether developing an AI algorithm with different cell types could potentially do something more efficiently, even for very simple things, even for a deep net And then maybe there can be 3 or 4 classes of things to test this with. So one thing could be a simple, like vanilla grid-based algorithm. Another thing could be like a little bit more sophisticated, and see, does it hold up? Does it also scale, etc.? Or do you really need like large organizations for this to matter? So I really like that as a point of ending. Does anybody want to say some last famous words for 2020 before we meet again next year?
I would like to say something to address Laurelin's earlier question of what we've learned this year, because we all mentioned the things we've learned kind of cognitively and intellectually, but I think the thing I gained the most this year from the Salon is how to be a better person in a diverse community of intellectuals that spans disciplines, ages, backgrounds, all these things. It's been really unique for me. At our institute, we have seminars weekly, and there's 40 people on a good week. And it's a relatively homogeneous group of people. And here we have between 150 and 250 people a week, and it's a much more diverse group. And it's such a joy to be a part of it, and to learn how to be a better part of a community like this. And so that's, I think for me, that's the best thing I got out of the Salon.
Community is everything. That's what we, another t-shirt. Oh, you have a comment? No, okay. So I want to thank everyone who has been participating. I want to thank everyone who's arrived on screen, anyone who's been in our chats, everyone who we didn't manage to get to their questions, because everything every time gets so exciting. And I wish people carry over their questions to the sessions that are the wrap-up sessions, because we might forget, and I always feel bad about that. But it's been feeling quite great. This session especially, I really loved this wrap-up even more than the last wrap-up, and I thought that was like a highlight. So this is, yeah, maybe it's a recency bias, but probably next year I will feel even better about our wrap-up. I want to thank everyone who has inspired us, everyone who gave a talk, all our speakers, everyone that will become a speaker in the future. And I want to thank Jovo for being the persistent driver of this starting in spite of everybody's skepticism in 50 different directions. I want to thank Kanaka and Brad for being the champions of the chat situations when we couldn't see things. And I want to thank Melanie for always asking the most wanted question, in addition to giving an awesome talk and always having thoughtful things to say. I want to thank John, although he's not here. Both his style, his vocabulary, and the spice that he uses when he's talking about anything with a certain level of provocative style. I think it's just added to the soul of the Salon a lot, in addition to the inspirational intellectual things that he says. And I just want to thank everyone for creating a sense of community during the pandemic, and while some of us are quarantined, like, you know, very far away from our loved ones. And it's lovely to have a sense of community in spite of the fact that there's no workplace to go to. You can't visit some of your friends that you used to see at conferences. So the fact that we can see some of you here is awesome. Yeah, I wonder whether anybody else wants to say.
The other people I'd like to thank, and you did a great job of thanking people, is people who've been critical of the Salon, both privately and publicly. So Ida and I know about lots of private criticism that we've received, and there's also been public criticism on Twitter and other places. And we really appreciate it. Sometimes it's hard for us to hear, but I think we've thought about it, and I think made it better because of it. And so please continue to be critical so that we can continue to improve it.
Thank you. That's a very good point. Yeah, my Twitter handle is Critical Neuro, so I should better like critical comments by others. Any other things our guests on screen want to say before we close the session? Okay. Happy 2021, everyone. I'll see you on the other side of this year. Goodbye.
Bye. Happy New Year.
Thank you, Eva. Thank you, Claire. In case I forgot to mention you again.